For the last 2.5 years, we've been innovating on a platform that allows us to really elevate the whole AI machine learning conversation from a lot of data scientists getting manually involved, analyzing data, identifying features, and building models manually, to a set of meta algorithms that can do the model building for them. So as we scale AI to the next generation of applications, as we want to apply AI now to a huge number of machines and assets and scenarios, clearly you can't apply human talent at each one of those places. So AI here is being used as the mind of a data scientist. And that is something we call automated model building. That'll be clear through this presentation. Okay. So one of the things that I like to start with is this expression which I have adapted from Mark Andreessen, and for the last couple of years, often I've started my talks on this, is that software is eating the world and AI is eating software. And I feel that this is something that is particularly relevant to a group like Honeywell. Software is eating the world. What does that mean? What that means is the bulk of the economic value in systems, in processes, is now being captured and embodied as software. The complexity is migrating to software. And at the same time, as Steve said, the software industry is being reinvented. So every conventional area within software will be reinvented as an AI category. So there is a massive disruption coming from an industrial perspective, from a commercial perspective, but this creates a ton of opportunity. Just a couple more things before I get into specific examples. A lot of people have asked, well, why is this third coming of AI really working out this time? You know, we've heard it before. We remember the 1956 Dartmouth conference. We remember the neural network craze in the 80s. That didn't work out. Why is it going to work out now? Is it just hype? Well, there's 3 reasons that are principally cited for why this is working out. And it is working out very measurably in many, many applications. Data, compute, and algorithms. You all heard that, so I won't really talk about that in and of itself. But what I want to point out is that because I'm speaking to a Honeywell audience, if you look to find your company in these sub-bullets, there are many that essentially represent Honeywell businesses. The fact that the IoT is working is because of all of the work you have done over the last many years and decades in building, designing, and proliferating sensors all over the place. The work that you've done in automation and what you can do in terms of actuation, which is, in my estimate, the next evolution of the IoT, that's something that you have been doing for many, many years. Similarly, on the compute side, sure, not every kind of compute, but compute at the edge, where decisions need to be made very rapidly at the edge, you have the capability to do that. Where we've come in as a partner, and I'll show you some of the work we've done collectively, is on the algorithm side. We are an algorithms company. We have pioneered this automated model building capability, again, replicating the mind of a data scientist, not trying to directly solve the problem, but elevating the scalability of how you can solve these problems. You've heard of deep learning. Deep learning is all about recognizing patterns very, very effectively. Recognizing voice very effectively, recognizing images very effectively, recognizing video very effectively. It's a perception capability. Reinforcement learning, which many of you may have heard of, others may not have, will be the next step, and you will start hearing about this. This is about where our artificial intelligence systems will learn how to optimize a set of actions to get from one state to a goal state. So for example, a self-driving car uses some nascent reinforcement learning techniques. Autonomous aircraft, autonomous commercial aircraft will use these techniques as well. But these techniques you will find everywhere. And in many of the scenarios I'm about to show you, hopefully you'll get a deeper appreciation of that. The rest of this presentation really is structured simply as examples and scenarios. These things that I'm about to show you mostly all exist. The things that don't exist or are at the concept stage, I'll point out and I'll tell you what exists and what doesn't exist. So this is all real. And we are a company that operates at the absolute cutting edge of AI. One of the things that we've shared with our team is that we will not solve problems that have been solved before. We are only in the business of solving unsolved problems because that is the Aboriginal definition of AI. Extending the capability of human intellect into domains that have been untouched. With these categories, hopefully many of you here, business leaders across business units that probably know much more about each one of these areas than I ever will, but greater automation. I'll give you an example of how AI is fusing with robotics to create very, very inexpensive and very configurable robotics capabilities. I'll give you examples on cognitive prognostics, the fusion of artificial intelligence with augmented reality. The important thing here is not just the AR. I know Honeywell has wonderful AR capabilities. Many companies are working on the hardware for AR. The question is, you've got this headset, what do you show? What kinds of capabilities do you imbue in that experience? And can you predict the future of a machine that you're looking at? Can you look at an asset and detect if this asset is under cyber attack? These are the kinds of things we'll walk through in this example. Prescriptive assistance for humans. And I still smile when I have to add for humans at the end of anything. But I suppose in this new age of artificial intelligence, we need to make those boundaries clear. So here I will showcase some work that a fantastic team at Honeywell did with us on the aviation side to really create a cognitive layer on top of tons and tons of AFMs and technical manuals for aircraft and PDFs that couldn't even cleanly be ingested into a system. And we took that mess of documents and made it into a cognitive system that can support deep Q&A. So I'll give you an example of that. Safety through autonomy. Like I said, deep learning is about perception, is about understanding. Reinforcement learning is about planned action. So safety through autonomy, I'll show you an example of where we're applying our reinforcement learning platform to automate an experience, and you will see a side-by-side comparison of the state of the art today and this AI-based system, and the safety aspect will be quite obvious to you once I get there. And then finally, cognitive security, which is, as you saw these days, we have the WannaCry malware. It's all in the news. It's now penetrated over 100 countries. It's shut down hospitals, impacted banks, and so on and so forth. So I'll show you, and by the way, this was blocked by SparkCognition Deep Armor the very first day without a signature. I'll show you an example of not just this, but performance AI versus traditional on 50 pieces of malware. I'll show that to you running. And the final thing that I want to say, and I actually should probably check here, are there folks from the defense business here in this audience? If there are, if you could please raise your hands. Okay, a few over there, a few over here. Okay, so not too many, but that last scenario to me is very important, and it's not here to scare anyone. The scenario is very important because our board member, General John Allen, who's a 4-star US Marine Corps general, recently retired, ran all 3 of our wars in Syria, Afghanistan, and Iraq, has been working with me very, very closely in determining how artificial intelligence can be applied in the battlefield in a moral and an ethical way, and what our adversaries are doing. And the reason I bring this up is because this truly is A, of national interest, B, of commercial interest to Honeywell and many of the groups here that are represented. So I want, in the spirit of being a partner, want to expose you to some of that early thinking through a scenario. So this is how the rest of the presentation will go. Okay. So the first example is cognitive robotics and a factory on a desktop. We're all familiar with robots that can be programmed to run a certain track and do their job, and then they're done. This is MakerArm. It is a very low-cost robotic system that was built in Austin, Texas, and for full disclosure, I'm involved with the board of this company. On the lower left-hand corner, you will see that multiple MakerArms are also collaborating. For under $10,000, this device can do 20 different functions, from laser to milling to pick and place to 3D printing to routing to painting, drawing, you name it. It can assemble electronic components. It has a vision add-on that can identify components and sort them. And like I said, more than one of them can collaborate at one time. This is not traditional robotics. There are a number of things happening here. One is learning by example. This is going to be for anybody here involved with robotics. You may have heard this term, but it's going to be huge for you. You should look into this. Learning by example, collaboration, being able to provide a workload to one of these systems, and if one happens to be available, then it does the job. If 6 happen to be available, then all 6 of them start to collaborate. They build their own plans. They use AI to determine the best possible way in which to solve a problem. So you put 3 or 4 of these on a desktop, you literally have a factory on a desktop. And what's enabling this is not the bent metal. What's enabling this is software. The next scenario that I want to walk you through is an AI and AR scenario, which is, again, very real. This is powered by our SparkPredict platform. SparkPredict ingests sensor data from a variety of different systems, from data historians, from data acquisition systems, and processes that to create these automated models that can then predict when machines will fail, whether machines are running in an optimal state, and it works side by side with our machine learning security product to identify whether any of the assets are under attack or have some sort of a cyber threat impacting them. So here you're going to see a scenario which is a real scenario. We've collaborated with Microsoft to develop this on HoloLens. So you have an individual picking up a HoloLens set, and as he picks up the HoloLens set, he's in a factory floor-like environment. He sees a variety of different pumps. He sees a mini-map showing all of his assets up on top right. He sees a red flashing indicator that says that there appears to be a malware update. Firmware that was sent to the system may have been malware. That was detected. He then moves around and sees another little red flag that hovers in his AR experience. So he steps down and tries to figure this out. He can't, so he asks a question in natural language. With our deep NLP capability, his natural language questions are answered very simply with content that has been gained from thousands of manuals. And it provides a step-by-step guide, not a chapter, not a book, not a page, but a step-by-step guide on what to do. All of this has been cognitively put together. So he tries to go through this process and perhaps isn't very skilled at doing this. He realizes that he really needs some help. So within this system, we have the capability to contact other experts that have solved this problem before. Of course, the system remembers who's solved the problem before. And while these two individuals are conducting their dialogue, the system is interpreting their responses to text and saving those. And it remembers that the solution that was provided for any one of these fixes, what context, what asset, what were the words that were said, who said them. So this is an example of AI-AR fusion. I mean, in just about a little over a minute, there's a lot more here. AI-AR fusion, the fusion of safety and security in an industrial context, and human augmentation, i.e. encouraging a human being to attempt fixes, resolutions that they would otherwise not have known to do. So this capability, SparkPredict, is now deployed with a large number of companies. A big chunk of US wind capacity runs on SparkCognition. Of course, Honeywell is a client, but in addition to that, one of the largest aviation companies in the world is a client. And at this stage, over 60 of the largest companies globally are using this technology. Let me give you another example. Prescriptive assistance for humans. And this really walks you through, if you haven't seen it before, the user interface of an application that is powered by deep NLP, which is our natural language processing capability, but deployed within a Honeywell front end. And it's been designed specifically for aviation use cases. Of course, it can be extended to use cases beyond that. But the way this works is that we took thousands upon thousands of documents, manuals, guides, and ingested them into our natural language understanding system. Now, before an aircraft lands, about 30 minutes before, say, a Dassault Falcon lands, it provides an error code that indicates what potential problems might have been encountered during flight. This system is available as an iPad application with the maintenance worker, and it goes out, takes the interpretation of that fault code, and weaves together the exact prescription of what needs to be done to remedy the issue. The key here is it weaves together. It is not taking one sentence from one document. It is not taking one paragraph from one document. It is piecing together from all documents that might be across multiple vendor families, because it gets the first one and then it reads that and it says, oh, there is a reference here to removing the cowling. Well, removing the cowling wasn't built by, say, Hughes, it was built by somebody else. So now I need to go and find that manual. What you're seeing now is a cognitive overlay on these documents. So all of these documents have now been, these are familiar to you, these are your documents. All of these documents have a cognitive overlay. You can ask natural language questions. How do I replace the APU fuel control assembly? And this massive corpus responds with just one answer on the left. All of these documents are being structurally parsed, so linked images, diagrams, these are all being extracted. And here you have an example of many such solutions. So both things, the ability to take an error code and drive an entire prescriptive workflow using only documents that were designed for human consumption, number one, and creating a cognitive layer over all of your documentation to allow automated linking, referenceability, the construction of responses that need more than one document to provide the original content, and so on and so forth. Safety through autonomy. This is an area which is actually near and dear to my heart. For so long, all control has been explicit and discrete. And if you think about it, control is about making decisions. And decisions lie on a surface. They lie on a continuity. So when we model this surface with if-then-else clauses or explicit rules, what we really do is we wrap what is a surface with a very broad mesh. If the universe favors us, and we find a decision that has to be made at the intersection of that mesh, hallelujah. But if we find a real-world condition that puts us in the middle of that hole, of that gap in the mesh, we don't know what to do. Artificial intelligence systems learn response surfaces, which is why they can take a few examples or a large number of examples and get from it experience that was not explicitly communicated to them. This is a very, very important capability. Now, we publish AI papers, we have AI patents, we actually, invest a lot in taking the science forward in addition to building these products. And I can tell you that there are many, many other breakthroughs coming. There are breakthroughs around being able to show these algorithms one or two examples and for them to learn like a human child. This seems sci-fi, it is not sci-fi. It is coming. Steve was there in New York just about 3 years ago. He saw the state of the art that we had then and the state of the art that we have now, and I'll check with him later on, but I think a few things have changed. We go like this another 3 years, I'll tell you, there'll be a lot more. This field is progressing very, very rapidly. Let me talk about cognitive security. So what you have on the left is an anonymized world number one antivirus software. And on the right hand, you have SparkCognition's Deep Armor, which uses machine learning to identify the DNA of files and determine whether these files are attempting to do something bad. It does this with a technique called machine learning-based static analysis. So what's happening is that there's a file with 50 new pieces of malware. and a folder rather. The software on the left detects 6 of them. You see the big number 6 around the middle of the left UI. You see the big number 6. On the right-hand side, 50 threats have been detected. And in that big list where you see orange, red, and yellow bars, that indicates the likelihood of the threat having been detected. So this is the difference. If you just follow the SparkCognition Twitter feed, you'll see pretty much every week some zero-day attack is caught. Most recently on Friday, it was WannaCry. And the reality is that everybody else that catches attacks like these, they find them once, their customers have been impacted, then they scurry, they generate some sort of a signature, they push out the signature, and then they say, oh, we blocked 21 million attacks. Yes, after the first 3 million, were made susceptible to the same type of threat and attack and lost all their data. So again, safety and security. In the world of the cyber-physical, safety and security will come together. Safety, where you understand systems based on sensor data and can keep them safe from natural failure, where you can plan replacements, where you can be much more efficient than just MTBF, where you can go beyond simple pattern recognition, where you can revolutionize and wrap your infrastructure in this cognitive layer of insight and meaning, and security, right, which is things like cybersecurity. Everything that I've shown you, with the exception of the cognitive robot, was powered by these 4 products. These 4 products are available now. All of them use artificial intelligence. All of them work on structured and unstructured data. Deep Armor provides endpoint cognitive defense. Spark Predict ingests sensor data to enable the safety of machines by making predictions, such as with our partner Flowserve. We extended their pump failure forewarning from 4 hours to 5 days. Invenergy, which is the largest private operator of wind turbines in the US, is now using this technology on 1,100 of their turbines. Duke Energy, of course, our friends at Honeywell, and many, many others. Spark Secure is able to take unstructured log data from security systems such as firewalls and so on, and is able to interpret that data to identify threats that may have already entered the organization or are attempting to enter the organization. And then finally, Deep NLP, which really takes natural language processing forward.